I'm Anil Kumar, and in this video we will learn three different techniques of finding vertex from a given quadratic equation in standard form. So in general, when we say standard form, we are given the equation as y equals to ax square plus bx plus c, right? So that is in general the equation. So you'll find that this equation will have a vertex at x value of minus b by 2a, right? So if I substitute this value, then you get the y value also. So that is like in general you can find this value. Now how do we find this value? We can actually show it in many different ways. One of them is completing the squares itself. So you can follow the process of completing the squares and find the value. Okay. Now so what I will do here is I'll take a very simple example to illustrate. So let us take a quadratic function, which is, let's say, y equals to. We can also work with general case, but it becomes too complicated, right? So let's take simple example. So let us say we have a quadratic function which is x squared plus 2x minus 8 to begin with. Now let's say this is the function given to us, and we want to find the vertex. So we'll use this formula and say, well, we are expecting vertex at x equals to minus b by 2a. In this equation, b is 2, right? This is 2. So it should be minus 2 by 2 times a is 1. Okay. So minus 2 divided by 2 is minus 1. So x value of 1. If x is 1, what is y? Y will be, I'll substitute this value minus 1 here, minus 1 square plus 2 times minus 1 minus 8. So we get 1 minus 2 minus 8, and that is equals to 9 negative, right? So minus 10, 9. And therefore, we find that for this particular equation, the vertex is at x value is minus 1 and y value is minus 9. Is that okay? So that is how we found the vertex for this equation. Well, there are other ways also to do it. So this was for a standard form. This is probably the best way to do. The other way is you could do completing the squares, right? Or you could factor. Okay, so let's look into completing the square. So we found one method. This is to use that formula, right? So now we will use second method, which is completing the squares. So what do we do in completing the squares? So we'll again begin with the same equation, which is x squared plus 2x minus 8. We'll consider these two functions. We have x squared plus, this is y equals to, let me write, right, equals to. Half of 2 is 1, so we'll say 2x plus 1 minus 1 minus 8. So these three terms form a perfect square, which is x plus 1 whole square, minus 1 minus 8 is minus 9, right? So you get the vertex form. And from the vertex form again, you see that the vertex is at minus 1 minus 9. Do you see that? So we could easily do it with completing the squares. Third method is to factor. How do we factor? So we'll do product and sum to factor. We have x squared plus 2x minus 8. We're looking for product of minus 8, sum of plus 2. So plus 4 minus 2 will work. So it is x plus 4 times x minus 2. Now if you look into this parabola, it has 2x intercepts. One at minus 4, the other one is at minus 2, right? So I hope I'm not going very fast on this. Let me kind of sketch this. Okay, so we have two intercepts, x intercepts. One at minus 4, the other one at 2. And if I write x equals to 0, I get minus 8. That's my y-intercept, right? So what we have is kind of like this, a parabola which goes like this. Is it okay? where the values are minus 4, this x-intercept, this is 2, and this value is minus 8. Is that okay? Perfect. Now where is the axis of symmetry? It is midway between the two, right? So it is somewhere here. So axis of symmetry, x equals to midway, is between minus 4 plus 2 divided by 2, which is minus 1, right? So we find again that minus 1 becomes the axis of symmetry. And if I substitute minus 1 as I did earlier, I'll get y equals to minus 9. So I get exactly the same value. Do you understand? So these are three different ways in which when an equation is given in a standard form, we could find the vertex. Now factoring, as you know, may or may not work always, correct? So that is kind of important to understand. So let me give you, since this does not really always work, a partial factoring, which always works. So I'll discuss the fourth way here, which is called partial factoring. That is a very, very powerful technique. However, it is not being used so often. Let's do it with partial factoring. We have y equals to x squared plus 2x minus 8. I know I've taken a very simple example, but it works, right, to make you understand how we should be working with. So partial factoring is to factor these two. So you could always factor x from them, right? So we get x plus 2 here minus 8. Now that gives you an idea. The idea here is that, let's get back to the previous diagram, that if x is 0, then what is the value of y? It is minus 8, right? How about when x is minus 2? Think like this. If x equals to 0, y equals to minus 8, right? Because if x is 0, this term is 0. So y is equals to minus 8. When x is minus 2, even then y equals to minus 8, right? So you can see here that if I draw a horizontal line, then at minus 2, I have the same value of minus 8 as I have at 0. And x's should be midway between them, right? So that gives us x's. A horizontal line, and from the symmetry, since the y values are minus 8, both sides, we actually call it reflection or image of y-intercept. Important thing, right? So the axis is midway, so which is between minus 2 and 0. So it is minus 2 plus 0 divided by 2, which is minus 1. So again, you get the value of x's, x equals to minus 1, which you could substitute and find y. Do you see that? Minus 1 squared plus 2 times minus 1 minus 8, which is minus 9. So again, we get the same value, minus 1 minus 9. Right, so that becomes the fourth technique which can always work, right? That's very important. So what we have learned here is that there are 4 different techniques which can be used to find vertex when the equation is given in standard form, right? You could use any of these 4 techniques and find your answer. I'm Anil Kumar, and I hope that really helps you to understand the concept. You can always share and subscribe my videos. Thank you and all the best.